Okay, last time we did the roulette simulator. Any questions on this piece? Maybe the only one is this last question. How do you solve that last question? So let's say how much did you win or lose among all sets? Let's say I was $7 in the hole. How do you do that last question? We did. Yes, and you should have emails. So if you weren't here, um, get the email, and you need to do 10 sets of 50 roulettes, and then we can do the class stuff together. But you'll need to do that at home and fill it in, and then do this first part. Sorry, I should have opened with that. Okay, so I have $7 in the hole. How do I calculate how much I lost per spin on average? I did 500 spins, 50, 10 times. So I take -7 and I divide by 500, and I ended up losing 1.4 cents per spin, essentially. Okay. Some of you lost more than that. Some of you lost less than that. I will show you the results here in a second. Okay. 500. Yeah, because you did 500 spins. Yeah, per spin. All right. So if we look at the data for the class, this is what it looks like. And again, some of you aren't going to be on this because you weren't here, but you can still use these numbers. So the first question says, how many sets of 50 did the class simulate? So let's look. Actually, there's an easier way to do this on my end. I need to pull up the roulette simulation page. Okay, 208 responses, which means there are 208 sets of 50, which means 2 of you screwed up. Why? 208 is not divisible by 10. So there were 21 people here yesterday. 2 of you did not submit, or maybe it was one person twice. It was probably Cedar twice. So anyway, we'll just run with it. 210, that's what happened. 2 of you messed up. I don't know which 2 it was because it doesn't keep very good records, right? Yes. And you, oh, it was you. Oh, so she got 0 twice and she didn't submit it. Okay, that's okay. So let's write down 210 then, because that's not going to change our end value, but it is going to change our average. Okay, so Cambry did screw up twice. For all future generations listening to this video, it's Cambry Bennett. Okay, she messed it up. Okay, so the answer to the first question, how many sets did the class simulate? 210 sets. How many total spins is that? So 210 times 50 is 10,500. Now, is 10,500 enough to have a pretty reliable result? Yeah, probably. The law of large numbers says eventually we should get numbers that are really close to the expected values. And we've talked a little bit about expected values in the past, but that's mainly what today is about. Okay, next question. What was the sum total of winnings and losses for all the spins in the class? And that's right here, -118. Okay, which really isn't that bad, right? I mean, if one person were to do this, how long would it take you to do 10,500 spins? A long time. And you only lost $118. So it's looking like this game's not so bad, right? we did lose money, $118. But remember, when you're gambling, you get free drinks. Well, so my purpose on this assignment was to show you that gambling is simply not worth it. Now, if we look at the people, most of the people lost money. Poor Megan lost 60 something dollars or more. Megan lost $60, but Josh won 40, what, $52, $57. Okay? But overall, most people lost money. And you will not be able to find a roulette wheel anywhere on earth that only lets you bet $1. So if you bet $2, what happens to this total? It doubles. A lot of roulette wheels are $10 or $20 wheels. So now we multiply that by a lot more. Okay? And we're going to check to see if this roulette simulator is accurate, because it might not be. Right? It might not be giving accurate numbers or truly random numbers. Okay, next question. How much money did the class win or lose per set of 50 spins? How do we find that? So we take negative 118, divide it by, nope, this is per set of 50, 210. Not 208, Cambry. 210. And I get negative 0.56. What does that mean? Oh, right there. Hey, I did it. I did it for you. It's right there. What does that number mean? Every time you play 50 spins and you bet $1 on red, you're expected to lose 56 cents. Now it starts to seem a little less appealing, right? Okay. Now, is that number accurate? Well, we'll find out here in a little bit. And remember, if you bet $2, then every time you spin 50 times, you're expected to lose $1. And that's not very much of an edge. But remember, lots of people are in lots of casinos betting a lot of money. And in the end, the casino is skimming a little bit off the top. But they're always skimming a little bit and they win. What if you go play poker? How does the casino make money there? Does the casino doesn't, well, there's video poker. Don't ever play an electronic game. That's just silly, right? I mean, it's programmed to make you lose on purpose, and they track how much you win and lose. So don't gamble, period. But slot machine, anything electronic, bad idea. It's not worth it. So what if you go play poker? So 4 of you and me sit down at a table in a casino and we play poker against each other. How does the casino make money on that? There might be an entry fee to play. That might happen. I don't know. I've never done it. So maybe. How else do they make money? The dealer makes money how? Because all the money, the casino does not own any of the money. I bring my money, you bring yours. We all sit on our edge of the table. We all bet our money. And maybe we paid to get in. But how else does the casino win? Well, every time somebody wins a hand, the casino gets a cut. Right? All the money piles into the middle, and everybody folds but me, and I go and I scrape all the money and I bring it to me, and the dealer says, wait a minute, 1% of that belongs to the casino, or I don't know what it is. Right. So if you played for a really long time, you could end up losing. And maybe it's $1 per pot or something like that. I don't know what it is. Yes. Yeah. But there's a percentage or maybe a flat rate that gets scooped into the dealer's bin every time a pot gets paid out. Okay. All right. So, next question. How much did the class win or lose per spin? So I'm going to take that negative 118 and divide it by 10,500, and I get 1.1 cents per spin, which doesn't seem like a lot, right? but the casino has an obvious advantage. Okay, and then below, draw the histogram. So we're just going to do a normal curve. So the normal curve, which is based at negative 0.56 with an SD of 6.7. So, oh my goodness. Do you know how many times this has crashed on me today? Way too many. Okay. So this is the histogram for 50 spins. And the histogram says, hello. Thanks. The histogram is centered on the average of negative 0.56, 56 cents per spin. Okay, and the SD is 6.8. Okay, and the question says, what's the chance that you spin 50 times and you win money? So we want to know what is to the right of $0. This goes back to chapter 5. So we take 0 minus, wait, other way around. It's always, no, it's value minus average. 0 minus negative 0.56 divided by 6.8. So 0.56 divided by 6.8 gives us a z-score of 0.08. Okay? How do I find the percentage now? Shade norm from 0.08 to 5, or any number bigger than 5. So we'll shade norm from 0.08 to 5. What do we got? Oh, I got an equation in there. That's not going to work. Let me try that again. 0.08 to 5. And we get 0.46. What does that mean? So if we play 50 times, 46% of the people will come out ahead. Right? That seems pretty good. Okay? But what if you keep playing? Because it looks like the bottom is a lot more than 46%. Maybe the bottom, or sorry, it looks like the top is less than 46. It might be 30% or something like that. Why is that? The more you play, the more you're going to lose. And there's also another calculation that you guys aren't aware of yet. That so this chapter 5 stuff that I just did isn't totally accurate with what we're doing, and we'll get to that later. Okay. So what do you think? Are you going to play roulette? Well, turn the page. We're going to look at something else. Okay, on the previous page, we simulated a large number of roulette spins. In the long run, we would expect the average loss per 50 spins to be somewhere near the expected value. So we have an observed value, what happened when we spun the wheel 10,500 times, and there has to be some actual expected value. We don't know what that is yet. We're going to calculate it. And in order to do that, we have to look at how the game is set up. So we're now going to calculate that expected value when betting $1 on red. So the wheel can either land on red, black, or green. So we are going to bet, write this down, we're going to bet $1 on red. Okay? What happens when we land on red? I win $1. What do you mean by win $1? I get my dollar back and I win another $1. So in the end, so I spent 1, so I had minus 1, and then I added 2 to that for a total of plus 1. Okay? What happens when we land on black? I simply lose $1 and it's gone. Okay? What happens when I land on green? I lose $1. All right? How many red squares are there on the table? So there are 37 squares. So this is European. So there are 37 squares. One of them is green, which means there are 18 reds, 18 blacks, and 1 green. Now in American roulette there are 2 greens, a 0 and a double 0, because hey, our casinos want more money than European casinos do. Okay, now this is all kind of confusing and jumbled. Everything we do from now on essentially is going to be turned into a box model where you draw out tickets. If you have tickets in a box and you're able to randomize the tickets and draw them out, that is essentially the same as playing roulette, except, you know, there's not this fancy brass wheel with colorful numbers and all of that. Okay, so here is the box model. In the box model, there are red tickets and green tickets and black tickets. If the ball lands on red, what is the end result? You win $1. Okay? So how many red $1 tickets are we going to put in our box? We are going to have 18 tickets that all say plus 1. What about green tickets? There's 1 green ticket, and it says -1. Okay? And there are 18 black tickets, and they all say -1. So instead of putting your money on the table, all you have to do is reach into the box, pull out a ticket, whatever it says, you either pay or they pay you. Does that make sense? Now, does it have to be 18, 1, and 18? No. It could be 36 and 2 and 36. Or it could be 180 and 10 and 180. It doesn't matter. As long as the ratio is the same, it doesn't matter how many tickets are in the box. But it's a lot easier to make 18, 1, and 18. In fact, I can simplify this a little bit. How can I make this a little bit simpler? I can't do 9. Why can I not do 9? Well, I guess if you cut that value in half, okay, that would work. We could do 9 plus 1s, 1.5, and then 9 1s. Do the tickets even have to have colors? No, the colors don't do us any good. Okay, so I can get rid of the colors. Now that the colors are gone, what do you notice? Can I simplify this box a little bit? Right, I might as well just say 18 and 19. Does that make sense? That makes it a little bit easier, and it shows you that this is not a good game to play, right? Immediately you see where the problem is. Okay, so the next question, what is the sum of all the tickets in the box? So look at the box. We have 37 tickets in the box. 18 of them say plus 1, and 19 of them say -1. What happens when we pull all the tickets out and we count them up? I get -1. So the sum of the box is -1. That's not a good sign. Why? It means you're going to lose. Okay, so what does the sum of the box means? That is the expected loss when we draw how many times? 37 times. We are expected to lose $1 every time we draw 37 times. Now, is that going to happen to everybody? Obviously not, because we played this game thousands of times, and some people ended up winning. But on average, every 37 draws will yield -$1. Okay? So that's important. We are going to use the term sum of the box over and over and over and over. The sum of the box simply means we added up everything that was in the box and we ended up with -1, which is a bad sign. It means we're going to lose. Okay? Next question. What is the average of all the tickets in the box? How do we figure that out? We take the sum of the box divided by the number of tickets in the box. So -1 divided by 37, and I get, so the average of the box, I'm just going to call X bar, is -0.27. Nope. 0.27, right? 0.027. What does that mean? Every draw essentially is worth -$2.07. Okay? Now, anybody notice anything funny? They are. Go back. How much did the class win or lose per spin? We had 1.1 cents per spin. The actual value should be 2.7 cents per spin. So, and let's times that by 50. So 2.7 times 50 should be 135, nope, wait. 0.027 times 50 is 1.35. So the average per 50 should have been 1.35. Okay, now we're a little less than half. So I don't think this roulette simulator is accurate. Right? We were more than half off. Does that seem too far? It does. Where's the line? Where do we say it's too far or not too far? I'll teach you that someday, not today. Okay? And you kind of get to pick that, but that's where we're headed eventually. But we did 10,500 draws. We would expect to be really close. Okay? So how much should we have lost? I'm going to take 0.027 times 10,500. We should have lost $283 instead of -118. So this, ooh, this might be sinister. I wonder if, oh, that's evil. Do you see where I'm going? I wonder if a gambling company put together this roulette wheel and purposefully made it look like you don't lose as much as you actually would. Oh, I'm totally going with that. That's what happened here. It's not a mistake. It was intentional. So, I mean, they were off by more than half. So you should have lost $283. And instead, we only lost 118. No, that was about half. When we did the other version, it was about half. Right, yeah. Yeah. Okay, next box. In American Roulette, there are 2 green squares, so write out the box model for American Roulette, and let's just use the easy version. So we don't need the tickets to have any colors. We don't need to distinguish between black tickets and green tickets because they're exactly the same in the end. What do I need to change here in order to make this American Roulette? The 19 turns into a 20. Do you want to play this game? No. Bad idea. Okay. So what is the sum of all of the tickets in the box? -2. I have 18 plus 1s, and I have 20 negative 1s. Add those together, I get -2. Hey, what's up? Right there. Okay. What does the sum of the box mean? You're expected to lose $2 every 38 spins. Now that's not going to happen, but on average, that's the end result. Okay. What is the average of all the tickets in the box? How do you do that? -2 divided by 38, and I get -0.052. What does that mean? You're expected to lose 5.2 cents per spin per dollar. Okay? And that's why we chose $1, because it's scalable. We can turn $1 into $5 really easily. We just multiply the answers by 5. Okay? So if we were playing European or American roulette, hold on, phone call. So if we played American roulette 10,500 times, so I'm going to take 0.052 and times it by 10,500, we would lose $552. Okay? Now, if you end up being unlucky, you're going to lose more than that. Okay? So, bad idea. Don't play roulette. If you're going to play, the longer that you play, the more guaranteed you are to lose. If everybody played 10,500 times, nobody would be in the positive. So take how much money you're willing to lose, pick a color, bet it all at once. If you lose, go home and never gamble again. If you win, take your money and go home and never gamble again. Okay, you only get one shot at this. Also, the only way to truly win is to be the casino, because they always have an advantage. No. No. Of course not. All right. So let's look at a couple different games that you can play with roulette. So the next one, if you bet $1 on a single number in American roulette and win, you get your dollar back plus 35 more dollars. Set up a box model for this situation. Okay, so I'm going to write it out the long way just to show you. Let's bet on the number 6. So we're going to bet $1 on the number 6. Okay? If I win, what happens? I bet $1. If I win, I get my dollar back, and I get $35 in winnings. Okay? What if it's not 6? Then I lose my dollar. Okay? Well, how many ways are there to get that payout? 1. How many ways are there to get this payout? 37. Okay? So, in my box, what's inside there? 1 copy of 35 and 37 copies of -1. Okay, now, before you do anything else, would you rather play this game or red? Let's check. And some of you already know the answer because we talked about this before. So, what is the sum of the box? -2. Does everybody see that? 35 plus 37 copies of -1. So the sum, this is the symbol for sum. It's that weird E, it's a Greek sigma. The sum of the box is -2. What does that mean? You lose $2 every time you play 38 times. That's what the sum of the box means. If you draw out all of the tickets of the box, you end up losing $2. Now, that's not going to happen to everybody. Some will be higher, some will be lower, but on average, it will be -2. Okay? What is the average of the box? Well, it's -2 divided by 38, which happens to be -0.052. What does that mean? You lose 5 cents per play. Okay? Now, that's impossible on one particular game, but in the long run, you will lose 5 cents per play. Okay? All right, let's play a different game. We're going to bet on green. And if you bet $1 on green, you get your dollar back plus 17. And if you don't get green, then you lose. So what does the box look like? There are 2 green squares. What's the end result when you bet on green? You get plus 17. You bet $1, you win, you get your dollar back, and then the what croupier, wasn't that what it said in the book? Gives you 17 more dollars. So 17. What else could happen? You could have 36 copies of not green. Does it matter if it's red or black? No. And the end result of not green would be -1. So we're going to do the same thing we did before. What is the sum of the box? -2. Right? There are 2 ways to get $17. 2 times 17 is 34. There are 36 ways to get -$1. So 34 minus 36 is, the sum is -2. What does that mean? You lose $2 every 38 plays on average. All right. What is the average of the box? Would be -2 divided by 38. So the average is going to be -0.052. What does that mean? On average, you lose 5.2 cents per play. Okay. These last 2 questions are really important. So we're not going to use European roulette. These are American roulette. In the long run, what is the safest bet in American roulette? They're all the same. There actually is a really silly bet in there somewhere that is worse than the others. I can't remember. It's in the book. We'll run into it at some point. But almost every bet on a roulette wheel has the exact same odds. Okay? Now, in a single spin, what is the safest bet? If you're only going to play once, what are you going to choose? Red or black or even or odd or the numbers 1 through 18 or the numbers 19 through 36? Yes, anything that has a 1 to 2 payout is the safest bet. Why is that? Aren't they all the same in the long run? Yep. But what if you bet on one and you get it? Then you get paid $37. Yeah, the chance of getting the one is really, really low. So in the long run, they're all the same except for, I can't remember. It's like the 3 square Monty or something like. I can't remember what it's called. We'll find it in the book at some point. But in the long run, they're all the same, other than the one weird one that I can't remember. And in a single spin, you want to take anything that has a 1 to 2 payout. Even, odd, black, red, 1 through 18, or 18 through, or 19 through 36, any of those. Okay, do you kind of get a sense of how the box works? Because the box is going to become our friend. Whenever you can turn something complicated into a box, and you can get rid of the table, get rid of the dealer, get rid of the colors, and just focus on the money, then it ends up being a lot easier. All right, we're done.